In my work here at the laboratory, my focus has been on engineering and science for nuclear weapons. The stockpile is being maintained under stockpiled stewardship, but I would, in my opinion, I would offer the idea that stockpile stewardship also includes improvements in safety and use control if they can be reasonably accomplished. And that is what intrinsic use control is about. Intrinsic use control goes one layer deeper inside the weapon compared to what we have now, which protects the fully assembled weapon. Intrinsic use control goes one layer deeper in providing component use control, where the components will only function exclusively under authorization by the National Command Authority, that is, the President. But in an unauthorized manner, even the people who designed and built them would not be able to get them to function. The components, upon final assembly in the weapon, are initialized. And these components are given unique identification numbers, and they talk to each other on a digital communications network, mutually verifying each other's identification. And if one of the components is removed or one of the components is replaced, well, the system will look at it and say, I don't recognize you. And all the other protected components will become unusable. It's a very simple concept. But the next step is you say, okay, where do you get these numbers, these identification numbers? You want that to be secure. And you say, well, I want to use random numbers. I don't want to use a computer algorithm that creates things because somebody knows that computer algorithm. Okay, random numbers, that's great. Where do you get secure random numbers? Well, it turns out that contrary to popular thought, people typically think that radiation fields are constant in their intensity, but actually they fluctuate like a flickering campfire. And what you have in the nuclear weapon are radioactive materials, and the radiation field from that nuclear weapon, though very small, is fluctuating. And you can measure that. And you can use successive measurements to create a very long random number, and the weapon would create it. No one would ever know what that number is. And these identification numbers are created by the weapon. No one would know what those numbers are. Its simplicity belies the extreme security it brings to this situation, where even the most sophisticated intelligence agencies around the world would not be able to crack this process, now or ever.